Let's compare environmental taxes to tradable permits. At first sight, they seem very similar. Both reduce emissions, both equate the costs of abatement at the margin, thus ensuring cost effectiveness, and if auctions, both taxes and tradable permits bring revenue to the government. So they seem the same. However, if you impose an environmental tax, you do not know how companies and households will respond to that tax. You do not know how much emissions will be reduced. You do know that they will reduce emissions, but you do not know by how much. On the other hand, if you use tradable permits, then you have imposed a cap, and you know how much emissions will be reduced. But you do not know what the permit price will be. You do not know what the cost and the margin would be. Unless, of course, in both cases, you know everybody's abatement cost curve. If you know the abatement cost curve and you impose a tax, then you know how people will respond and how much emissions it will reduce. Or if you impose a quantity, then you know what the price of permits will be. But if you do not know this, and actually very rarely know with any kind of precision ex ante what abatement costs really are, the two are not the same. Tradable permits and taxes are only the same if you fully know, if you have complete knowledge of your economy, which you typically don't. So then the question arises, if the two are not equivalent, which one is better? And the answer to that was written up in 1974 by Marty Weitzman, a much younger Marty Weitzman, the late, great Marty Weitzman, I should add. So how does this work? Yeah, let's start with a diagram with quantity on the horizontal axis and price on the vertical axis. We have a marginal damage cost curve. If there's no emissions, or if the emissions are very low, the damage at the margin is very small, but as emissions grow, damages grow accordingly. This is the unregulated amount of emissions. If you reduce emissions by a little bit, it's going to cost you a little. But if you push emissions towards zero, then it's going to cost you more and more. So this is what you would expect the marginal damage cost curve and the marginal abatement cost curve to look like. The optimal price that you want to impose is P star. Or the optimal quantity, the optimal amount of permits that you would allow is Q star. And if you know these two cost curves, if you impose a tax P star, you're going to get the quantity Q star. And if you impose the quantity Q star, you're going to get the price P star. So that is the starting point. And this is the Samuelson equivalence between price and quantity. Now let's assume that the government does not know the abatement cost curve, the true abatement cost curve, and let's assume that it listens to industry, and industry claims that emission reduction is much more expensive than it really is. And let's assume that the government is convinced by the lobbyists that it's not the brown curve, but it's the red curve that is valid. In this case, the government would impose a total amount of permits of Q prime, not Q star, but Q prime. The government would under-regulate. It would allow emissions that are too high. However, if the government uses a price instrument, it would impose a tax. It would impose a tax P prime. That is, if the government believes that emission reduction is more expensive than it really is, it would over-regulate. In this case, the government did not listen to the corporate lobby, but instead it listened to the environmental lobby. You can, of course, turn this around and say, well, if you're a company and you believe that the government is going to use cap and trade rather than environmental taxes, then you should exaggerate the cost of abatement. But if you believe that the government is going to use taxes, then you should understate the cost of emission reduction, right? So you can turn it around. And of course, for the environmental lobby, it works the exact opposite way. So this is the first insight from the Weitzman theorem, not the key insight, but the first insight, that if the government does not know where the true abatement cost curve lies, then, and assumes it is higher than it really is, then with quantity instruments, with cap and trade, you would over-regulate, whereas with under-regulate, whereas with a price instrument, it would over-regulate. So the symmetry between prices and quantities is broken in this case. Now, in either case, the government makes a mistake, it deviates from the optimum, and that means that there is a net welfare loss. That net welfare loss, when using a quantity instrument, is as follows. You under-regulate, so there is an environmental loss, that's the area under the green curve between the optimal regulation and the actual regulation, and that's this area here. At the same time, there's a welfare gain, because you impose less of a burden on your polluters, and that welfare gain is the area under the brown curve, and that is this area here. And the net welfare loss is the blue triangle that you see marked here. If the government uses a price instrument, an environmental tax, there's also a welfare loss, net welfare loss, because you deviate from the optimum. There's over-regulation, so there is an environmental gain. That's again the area under the green curve, which you see here. But there's a welfare loss because you impose too much of a burden on your polluters, and that is the area under the brown curve, and that is here. And the difference between the two is the pink triangle. And it seems in the graph, and it's actually true, that these two welfare losses are the same in size. The distributional consequences are different. With under-regulation, you essentially have a welfare transfer from the environment to polluters, and with a tax, you essentially have a welfare transfer from polluters to the environment, but on net, they are the same. So we haven't learned anything about whether we should prefer taxes over tradable permits, or so you think. Now, what happens if the marginal damage cost curve is steeper than drawn here? Well, what happens then is that the blue triangle shrinks and the pink triangle grows. And the blue triangle shrinks because if this curve becomes steeper, then the distance between Q star and Q prime shrinks, and the distance between P star and P prime grows. That is the consequence of making the green curve steeper. Here we have the original situation, and now we make the curve steeper, and this is what happens. Because of that, the welfare loss due to under-regulation shrinks, and the welfare loss due to over-regulation grows. So in this case, if the marginal damage cost curve is steep, then the mistake you make with a price instrument, with a tax, is more costly than a mistake you make, an equivalent mistake you make with a quantity instrument with cap and trade. And the opposite happens if you make your marginal damage cost curve shallower. Then your blue triangle grows, and the distance between Q star and Q prime grows. The distance between Q star and Q prime grows. The distance between P star and P prime shrinks, and as a result, your blue triangle gets bigger and your pink triangle gets smaller. And in this case, if your marginal damage cost curve is shallow, you're more robust to mistakes if you use a price instrument, and less robust to making mistakes in your assumptions about the actual marginal cost of emission reduction, less robust if you use a quantity instrument. And it all hinges on the question, what is the steepness of the marginal damage cost curve relative to the steepness of the marginal abatement cost curve? And here we are back in the original situation. This is the Weitzman theorem. In words, if the marginal damage cost curve is less steep than the marginal abatement cost curve, then mistakes with price instruments, that is taxes, are less costly than our mistakes with quantity instruments, tradable permits. And in this case, you should therefore prefer taxes over permits. And if the marginal damage cost curve is steeper than the marginal abatement cost curve, then mistakes with quantity instruments, that is tradable permits, are less costly than our mistakes with price instruments, and in that case you should prefer tradable permits. This is a pretty powerful and general theorem. Of course, Weitzman did not prove this graphically, but he did so analytically. And it holds in general, and the only key information that you need to know for this to work is, if I change my policy, by how much do my costs change, versus if I change my policy, how much do the benefits change. So you only need to know something about the relative steepness. You actually do not need to know absolute levels or anything like that. But if you're in a situation where, well, if I make my policy a bit more stringent, is that going to cost a lot? Is that going to cost a little extra? And if I make my policy a little bit more stringent, am I actually going to save substantially in environmental damage, or am I going to save only a little bit? And if you know that, which is pretty low burden of proof really, then you know whether you should prefer taxes over tradable permits, or vice versa, prefer tradable permits over taxes.